Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by AWS and CloudBees. My name is Cody, and welcome back to Techstrong Learning. We have an exciting presentation ahead, but first, I need to cover just a couple of housekeeping notes with you. First of all, we are recording today's session. So if you miss any of our discussion, if you would like to watch again at a later time, or if you'd like to share with your team, you will be receiving that on-demand recording shortly after we conclude this live session today. So if you have questions, comments, concerns, there are a couple of ways for you to engage with us. The first option and the easiest option is to use the chat tab on the right side of your screen. So I'm seeing Portland, Oregon, Seattle, Tacoma, Texas. Let us know from where you're joining us whenever you find that chat tab. If you have any specific questions, we do want you to direct those to the Q&A section. Sending your questions to Q&A helps us keep track, and we'd love to answer as many questions as we can today. Now, if you jump over to that handout section, you'll see a couple of additional resources, so feel free to grab those as we progress through our webinar today. And before we close things out, I will be giving away two $25 Amazon gift cards. So be sure to stick around until the very end to see if you're one of our lucky winners. So today's topic is building resilient infrastructure, unleashing the power of high availability. And I'm joined today by Tim Hosey, Senior DevOps Consultant at CloudBees, and Venkatesh Aravamudan, Partner Solutions Architect at AWS. Tim and Venkatesh, it's such an honor to have you here with us today. Venkatesh, would you like to dive us straight into these slides and take it from here?
Sure. Thank you so much, Cody. Hello, everyone. My name is Venkatesh Aravamudan. I'm a Partner Solutions Architect at AWS, and my role as a PSA is to join forces with strategic ISV partners and help both of our customers. So some of you might have seen this slide already, something similar. Everything fails all the time. Any complex system is likely to have a mixture of smaller, more probable failures and larger and more rare failures over its lifespan. Because of this, companies must expect and plan for system failures and design workloads to recover from failure in a way that minimizes impact to their end users. As a part of your responsibility for resilience in the cloud, you need to think about resilience threat modeling. These are the categories of failures that you can use as a framework to do resilience threat modeling. Categories could be code deployments and configuration. For example, what happens when you have a failed deployment? Do you have the instrumentation to detect it? Can your CI/CD automatically roll back? Or another category could be in infrastructure. What if a single instance is terminated? Or what if there is an impairment to a single availability zone? Or another category could be data and state. This covers your data application state, etc. What happens if your customers overwhelm your service? What happens if your database gets corrupted? Or another category could be dependencies. What happens if a third-party dependency fails, or do you gracefully degrade? What if latency increases by 50%? And finally, also highly unlikely scenarios such as natural disaster that impacts power or infrastructure, or that. So what is resilience? Resilience refers to the ability of workloads to respond and quickly recover from failures. A workload might consist of a subset of resources in a single AWS account or be a collection of multiple resources spanning across multiple accounts. As we go through today's presentation, the mental model I wanted to think about are three things: how you can build systems to be highly available with resistance to common failures, how you can recover your system if you run into those rare failure scenarios, and this notion of continuous improvement. Resilience is not a one-time thing that you just check off your list. Continuous improvement entails things like implementing DevOps practices such as CI/CD to automate your delivery pipelines, introducing failures on an ongoing basis to test your systems, and implementing ongoing observability and monitoring practices. So, why resilience? Companies that think holistically about system resilience are able to achieve greater system availability, and that has a direct impact on your company's brand and bottom line. According to IDC, unplanned system downtimes cost Fortune 1000 companies anywhere between 1.25 billion to 2.5 billion annually. And that's just the financial cost. There's also your brand cost. Your end users count on you or your system or your service to be available when they need it. When it's not available or if it's performing poorly, it can have disproportionately negative effect on the perception of your brand. And why now? Um, Modern organizations today face ever-growing number of resilience-related challenges, especially as expectations from the customers shift towards always on and always available mindset. Remote teams and complex distributed systems, coupled with the increasing need for frequent releases, mean an organization and its system need to be available and be more resilient than ever. So, resilience is a shared responsibility between AWS and the customer. AWS is responsible for resilience of the cloud, and our customers are responsible for resilience of their workloads in the cloud. This shared model can help relieve the customer's operational burden as AWS operates, manages, and controls the components from the host operating system and virtualization layer down to the resilience of the infrastructure. More specifically, AWS is responsible for ensuring resilience of the infrastructure that runs all of the services offered in the AWS cloud. Uh, that encompasses hardware, software, networking, and facilities. So, customer responsibility here will be determined by the AWS cloud services that the customer chooses to use. This determines the amount of configuration work the customer must perform as part of making their workload resilient. Customers should carefully consider the services they choose as their responsibilities vary depending on the services used, um, the integration of those services into their IT environment, and applicable laws and regulations. So let's take a look at a few points about um, how AWS achieves the resilience of the cloud. In AWS, region is a physical location around the world where we cluster data centers. We call each group of logical data centers an availability zone. An availability zone consists of one or more discrete data centers, each with redundant power, networking, and connectivity, and housed in separate facilities. In AWS, we offer more than 200 fully featured services from 102 availability zones across 32 regions globally. Unlike other infrastructure providers, as I just mentioned, each AWS region has multiple availability zone and each AZ has multiple physically separated data center. By comparison, some cloud providers claim to have just over 50 regions, yet most of the regions have no availability zone and just one data center. So they are not comparable to the multi-AZ, multi-data center AWS regions. Also, each region has two independent, fully redundant transit centers that allow traffic to cross AWS network, enabling regions to connect to the global network. Further, we don't use other backbone providers for AWS traffic once it hits our backbone. In this slide, I want to talk about how our culture is built around resilience. AWS employs service ownership model, which incentivizes teams to continuously improve their operations. We organized our engineering and product management efforts to be led by small multidisciplinary teams. We call it two pizza teams with strong ownership of services they produce. This ownership brings responsibility for not only designing and launching the service, but also operating it during production and being on call for issues as they arise. Prior to launch, all services also required to be reviewed by operational readiness using our operational readiness review process. The launch teams they answer a set of questions around resilience along with other best practices. They use a standardized runbook to ensure their service meets the bar. After the service has been deployed, there are weekly operational meetings to inspect operational performance of the system as well as any open issues. And when AWS deploys software for updates or rolls out new service, we use safe continuous deployment pipelines, um, building automated deployment safety into the release process by using extensive pre-production testing, automatic rollbacks, and staggered production deployments lets us minimize the potential impact on production caused by faulty deployments. For example, updates to AWS services start small. The update is first rolled out to a single server within one availability zone. Then it goes through a designated waiting period to verify there is no issue. From there, the update is deployed to throughout the rest of the availability zone and then to other AZs and then to a single region and then to the remaining regions. Finally, I want to talk about the correction of error process. Um, if any issues arise, we leverage incident management mechanisms such as correction of error processes to help our teams understand the root cause. Um, After an issue is mitigated, we drive company wide engineering sprints to ensure the issue is fixed across other AWS services as well. These learnings are documented and become a part of our overall process. So now that we have talked about what AWS is doing to build resilience of the cloud, let's talk about how you can make your workloads more resilient in the cloud. Every organization has a different level of maturity when it comes to resilience journey. Some are just beginning, while others may be more advanced. The concepts I'm going to outline provide a good baseline of things you can consider during your resilience journey, but can be expanded upon depending on your business objectives and available resources to execute your resilience strategy. So we offer the most comprehensive set of best practices um, tooling, services, and guidance to enable your success. Let's take a look at how AWS enable your resilience in the cloud. With resilience goals, one size doesn't fit all. The AWS well architected framework, a series of architectural and operational best practices, encourages you to define availability and continuity of operational goals based on an available, excuse me, based on an individual workload's criticality to the business as against applicable one goal or like a single goal across all workloads. Establishing goals for high availability is just one half of the equation. It's also essential to create continuity of operational goals and define RTOs, the recovery time objective or the RPO, the recovery point objective metrics. Once you define these RTO and RPO targets, they can be input into AWS Resilience Hub. It's a central place for you to assess, validate, and measure the resilience posture of your workloads against your defined goals. And second point here I want to talk about is um, identifying and mitigating risks. After you have defined your goals, the next step is understanding what your workload's current resilience posture is and if there are any issues that need to be fixed. The AWS well architected tool, which is based on the AWS well architected framework, that can run your workload against 66 resilient best practices. It can identify risks and generate an action plan for you to remediate those. It also categorizes the risks into low, medium, and high so you can prioritize your remediations. While AWS well architected tool and the Resilience Hub help improve resilience of your workloads, the AWS Trusted Advisor helps improve the resilience of your AWS account and its resources. The AWS Trusted Advisor programmatically conducts a series of automated checks against five key areas: cost optimization, performance, security, fault tolerance, and service limits. And it provides recommendations that enable you to follow known best practices. Within the fault tolerance category alone, the, the trusted advisor features 23 checks that can help identify risks and improve resilience. Next, I want to talk about the continuous code refinement. So, part of building a highly available, resilient application is being able to identify and resolve issues in your code before it's deployed. AWS provides reviewing tools that not only augment the commentary on code reviews, but also recommend best practices around resilience. Prior to any deployment, it's a good idea to leverage Amazon Code Reviewer, Code Guru Reviewer, which uses machine learning and automated reasoning to identify critical issues, security vulnerabilities, uh, hard to find bugs, etc., during application deployment. And beyond code configuration issues, failures also commonly occur during code deployment due to manual deployment processes. One way to do configuration management is through implementation of continuous integration and continuous delivery, a popular DevOps practice commonly called CI/CD. Um, and the next point is continuous testing and assessment. Continuous testing is imperative uh, in understanding how your systems will react to unknowns. AWS Fault Injection Simulator is a fully managed service that simulates real world failures such as network errors or having too many open connections to a database and such. So it helps uncover hidden bugs, monitoring blind spots, and performance bottlenecks that are difficult to find in distributed systems. While this testing approach, which is also known as chaos engineering, was popularized in 2010 by Netflix with their release of their Chaos Monkey software. Amazon has been purposefully injecting controlled failures into limited environments since early 2000s, uh, just to increase resilience and ensure readiness under the most adverse of circumstances. Another popular testing methodology is the concept of game days, which simulate a failure or an event to test your systems, processes, and teams' responses. There are more details available about game days that can be found as a part of the AWS well architected reliability pillar. So the next point here is the continuous observability. Um, Implementing observability practices is imperative for resilient architectures. If you can't measure it, you simply can't improve on it. Um, with AWS availability monitoring and management services such as AWS CloudTrail, Amazon CloudWatch, or DevOps Guru, AWS X-Ray, you can run assessments, you can configure alarms or and synthetic user requests, you can detect behaviors that deviate from normal operating patterns. Um, you can also use the AWS Health Dashboard to understand when AWS events affect your workload. Finally, talk about recovering quickly. Um, Failures are inevitable, but preparation can help minimize that impact. So, to fail over gracefully, the underlying data that supports your application must be resilient, and proactively implementing some of the data resilience strategies, such as replication, redundancy, and backups, can help. So, services like Amazon S3, uh, Aurora Global Database, and DynamoDB, they provide multi-region support for data applications. S3 provides 11.9's durability. Services like RDS provide redundancy and durability of data by storing them across multiple availability zones. This concludes our introductory presentation on resilience at AWS. So we know that everything fails all the time. So we must design systems and help you design systems to accommodate failure in a way that minimizes disruptions. With these capabilities, tools, and processes, AWS can help strengthen your resilience and, as a result, improve your brand and bottom line. Thank you. With this, I'll hand it over to Tim.
Thanks, Venkatesh. I appreciate it. All right. So we're going to be talking about CloudBees CI. So CloudBees CI, we'll be kind of getting into what that is here in just a second. But we have a new feature called HSHA in CloudBees CI, which we're going to dive in depth into. I have some demos prepped so we can take a look at those too, and you can kind of see how it operates and how it works. But before we jump into that, I should introduce myself. My name is Tim Hosey. I'm a senior DevOps consultant, and I deliver the CloudBees Technical Success Management Program. I've been with CloudBees for about 3 years. The bulk of my experience was at a regional insurance carrier as a server admin, but after that, I moved to Chef Software doing implementation consulting, helping companies to get Chef Software up and running. And now here at CloudBees, I work with some very large clients, helping them to strategize and plan for the future and what their next steps are with specificity around CloudBees products, but really the whole gamut of DevOps in general. So that's kind of what I do. DevOps consulting at CloudBees is a subscription service that covers being a trusted advisor with whichever clients decide to engage with us. So what is CloudBees CI? Well, if you're familiar with Jenkins, you're familiar with CloudBees CI. So CloudBees CI is Jenkins for the enterprise. It is based off of the LTS releases of Jenkins, and it has some extra nuts and bolts tacked on that make it a much more enterprise ready and resilient, to use the terminology of the title of this presentation. It provides a resilient way of hosting your CI, whether it be on VMs, bare metal, or in a modern context in Kubernetes. So the question is, why high availability? Well, obviously, instability and poor performance on overloaded controllers. So a controller, for those who may not know, is in essence what runs and manages your builds within your CI context. So controllers can be overloaded. They can experience poor performance when it comes to whether it be builds that don't follow best practices, too many jobs running concurrently, and the like. So should those controllers fail or needs to be restarted for whatever reason, whether it be an upgrade, a change to the settings or configuration, or just a straight up crash, this can impact the builds that are running on that controller, as well as it can cause a user experience degradation from the users that rely on these controllers to do their jobs. In addition, we didn't have active high availability in CloudBees CI previously. So Kubernetes was our modern implementation, so we call that CI modern. And the multi-node nature of a Kubernetes cluster gave it a bit more resilience. So if, for example, a worker node in a Kubernetes cluster were to go down and take the controller with it, Kubernetes control plane would re-provision the controller on an available node to keep things up and running. But you'd have the downtime of the controller being re-provisioned and having to start up again. On traditional CloudBees CI traditional, which is, as I'd mentioned, hosting on VMs or bare metal, only had an active passive HA where you'd have to have a controller in a warm state, and if you had a failure, then the failover would occur, but it would be less reliable and in general more headache to set up than some folks really wanted to handle. So adding active gives a level of resiliency and gives us the ability to introduce new features such as rolling restarts and other related things like in the future, which isn't available at the moment. But one of the things that we're deeply investigating is rolling upgrades as well. So no downtime upgrades is a concept that we're also working on. Let's take a look at high availability architecture. I think one of my slides got skipped, which is quite interesting. Let me see why that is. Nope, we're just a little out of sync here. So let's take a look at a traditional classic controller architecture first. So a classic controller architecture is you have your web traffic, hits a load balancer, hits your controller instance, and then goes to the file system. In a modern HSHA implementation, we have the concept of replicated controllers. So this is handled in essence by using a replica set or a deployment in Kubernetes. And it is active-active, meaning you have multiple controllers, the load gets balanced across them, whether it be UI activity or job triggers, so webhooks, starting a job via the UI, that sort of thing, will get balanced across the entirety of your setup using a single shared volume as your file system. So in this setup, we at the moment require NFS as the base. So that means in AWS using an EFS, or in a self-hosted or on-prem solution using NFS as your option. So our high availability architecture covers web traffic coming in, hitting a load balancer, and getting a sticky session to a replica. We utilize Hazelcast to replicate state information and to help load balance jobs as they come in as well, and to keep things kind of managed in that regard using the source of truth, which is that shared file system. All right, let's take a look at the load distribution of replicated controllers. So you have your 3 replicas. These 3 replicas are kind of sitting, doing their own thing. And these replicas are each going to handle jobs, handle interaction from the UI. So we have job 1, job 2, and job 3, and job 4 all hitting different controllers. So these controllers are now handling their own jobs. But when a job is running, what do we do when a job or a replica fails? So let's say you have a complete failure of your controller. So let's take a look. Jenkins crashes. Well, let's take a look at what happens to job 3, which was on our second replica. It has now been rebalanced over to replica 3 because it has the available resources and availability to handle that replica. Now, when this crashes, that replica will detect as part of the deployment as being unavailable and will redeploy, or at least attempt to redeploy based on what the problem was. But this gives you some flexibility where your up controllers will still be servicing jobs and handling UI interactions. So they share that file system, so there's less worry since the file system isn't hosted directly on a controller. It's handled as a PVC within your Kubernetes cluster. And I'm speaking specifically to modern here, but looking at your PVC, these share a storage source using read-write many, so RWX, if you're familiar with the nomenclature within Kubernetes. So the new replica will start up and become available for the users to start using. So it'll spin up just like a regular CloudBees CI instance or Jenkins restart, where it'll come back up in the same exact way, but because they share a file system and Hazelcast is handling state and job balancing, it will pick up that the new replica is available and start bringing that back into the cluster as maintaining state and helping for jobs to be able to run on this node. All right, so let's talk a little about best practices when it comes to handling Kubernetes deploy with high availability horizontal scaling. So taking a look at the recommendations for sizing is really important. So sizing your Kubernetes cluster correctly is very, very important. Ensuring that you have enough storage, enough resources to handle multiple replicas, as well as agents if you want to run those in the same namespace or cluster. However, agents can be offloaded into different clusters entirely, or into different namespaces to handle resource allocation in that regard. And the same thing can be done for controllers as well. So they can, not necessarily the replicas, but as far as your high availability goes, you'll have the ability to shuffle things around as you please to ensure that you have the correct sizing and available resources for those jobs to run and those replicas to exist. If you're running this on traditional, which yes, HSH8 does work on traditional, it's a little bit more involved in terms of setup. I'm going to be showing here in just a few minutes how straightforward and easy it is to set up a replicated HSH8 controller in CloudBees CI. But in traditional, obviously you would have multiple VMs, so there's a little bit more configuration and setup there. If you're using a tool such as Terraform, that can be trivialized as well, depending on the amount of effort and work you put into, creating and standardizing those setups. So the CI traditional best practices follow pretty much the same concept. It's about sizing things correctly, ensuring that availability is there, and of course, making sure you have an NFS with plenty of space that can share a storage folder or storage location between your replicas. A best practice recommendation is to keep the operations center at the latest version to facilitate quicker upgrades of your controllers. For those who are unsure of what in the world an operations center is, in CloudBees CI, we have the concept of an operations center, which is in essence a controller of controllers. So it is a layer above controllers that helps handle licensing. It passes out certain configurations, and it brokers our configuration as code bundles to those controllers, as well as in a modern context, it does the management of your stateful sets or deployments for your controllers and ensures that they match with what your expectation is in terms of configuration. So the Operations Center pretty much follows the same concept, but has a different set of plugins and it has a different intent to be able to manage those controllers. So keeping that at the latest version can help ensure stability between your controllers and your Operations Center, and will really simplify upgrades as you move forward, as your Operations Center needs to be at least the same version as your controllers for you to upgrade to that version. And then controllers or replicas must be in a dedicated node pool. So ensuring that, again, that right sizing is done and that you have a dedicated node pool for your replicas to run, and ensuring that they can be up and maintain their state and restart as needed if things go wrong. That's really, really important. So ensuring that those replicas have a dedicated node pool is absolutely a best practice. Assigning lower priority class to agent pods so that controller pods are scheduled first. So this is primary for if you're sharing your resources, if they exist in the same namespace, if they have the same resource pool, ensuring that agent pods are scheduled at a lower priority means that you're ensuring that your controller pods are up rather than your agent pods. So controllers are the priority for spinning up your utilizing resources before agents, which are going to run your job. So let me explain that a little bit better. So agents are a kind of third layer. So you have your operations center, you have your controllers, and then you have your agents. And agents are, in a modern context, or CI modern, which is Kubernetes, a dynamic provisioning of agents utilizing images, specific YAML. We call them pod templates. And these pod templates define running the job. So they'll have your tooling on them, such as like Maven or SonarQube, and they'll run on the agent, which means that it's detached from your controller. So if your controller has an issue, your agent can be redirected to attach to another controller without any loss of your build. So this gives you a huge level of resilience that wasn't really an option in the very early days of Jenkins, where everything ran on the controller. And now with the concept of agents and the ability to offload your work, you can keep your controller lean and responding to UI and much more stable and performant than before. So you'll want to make sure that your agents either have their own resource pool, or if they share a resource pool with your controllers, just ensure that they are at a lower priority so they don't conflict with controller spin-up. And then adopting tasks within your Git-based workflow, using infrastructure as code for spinning up, AWS infrastructure. I use Terraform for my setup, which sets up everything on AWS for this demo. So I won't be going that in depth just because of the time it takes to spin that up. That's what I use. So utilizing infrastructure as code tools is definitely a best practice, but adopting CloudBees configuration as code is really, really important as well. So CloudBees configuration as code is, in essence, allows you to use YAML files to dictate the configuration of controllers, what plugins are installed, jobs that are set up. You can declare just about everything as code, which gives you a lot more flexibility, especially if you have an issue where you have to spin up another controller really quickly. You can utilize the same configuration as code bundle without having to really worry too terribly much about failures or unavailability of those jobs. And then the last point there, which is the middle point, is Helm charts for deployment and upgrades. Highly recommend Helm. It is our recommended method for spinning up a Kubernetes instance of CloudBees CI. So really important to use Helm because it makes upgrades trivial. It makes making changes to your operations center trivial. It's a very powerful tool and is a much better way of handling things than manual management of your various Kubernetes pieces. All right, so let's take a look at the demos. So we're going to go ahead and start right here on my operations center. So you can take a look. We've got our cloud operations center, and we have currently 2 controllers set up. We have a demo controller, which it has a single pod. It is a single, a classic controller where it is defined with a stateful set with a single replica. It does not have shared storage, and it uses read-write once for its backend read-write capabilities to the storage. It can also use EBS, which is another AWS option, which if you're using EFS, you have to use EFS for HSHA to work, but you can use EBS for your storage for individual controllers. Now, individual controllers support hibernation. Hibernation is a feature that we have that when a controller is not used frequently, it will just automatically be spun down to save the resources. And when you try to access that controller, it will come back and wake up and be ready to use as if it was never missed. Now, obviously, this is the opposite of what we want with HSHA because we want always available, highly available settings. So obviously, HSHA does not support hibernation. So 2 key differences there, but overall, you're still getting a similar experience. But if you wish to have highly available infrastructure, you absolutely need to utilize the HSHA setup, and you will not be able to take advantage of hibernation. Okay, so let's take a look at my setup here. So we're going to go ahead and take a look at what pods I have defined here. So I've already got, you can see there's 4 pods. I've got the CJOC, which is our CloudBees. It stands for CloudBees Jenkins Operations Center. That's our operations center. We've got the demo controller, which is that individual, that single stateful set. And we have 2 instances of our HSHA demo controller. So as you can see, there's 2 replicas of that. So if we take a look, we can take a look at our stateful sets. We have 2 stateful sets, one for our CJOC, one for our demo controller. Now, if you notice, the HSHA demo isn't here. And the reason that is because we're using a deployment for that. So if we take a look at the deployments, we have the HSHA demo controller deployed with 2 replicas. So it's up to date with 2, and it's available on 2, and it's been around for about 3 days. Now, if we take a look at what these stateful sets are versus our deployment, you'll see a little bit of difference here in the way that's done, but these are managed by my operations center entirely. So I don't even have to really manage this manually, but we can at least take a look at what this looks like from the perspective of Kubernetes versus what it will look like in the UI. So you can see here on this individual stateful set for demo controller, it kind of lays out all the information for it, all the annotations, and then obviously a layout of what defines the containers within. So in this case, we're using the Jenkins image, and we have this all set up as a single replica with no separate, no duplicates, right? So replicas, one desired, one total. That's just the way that we handle our stateful sets. Now, when we, as I mentioned, we use deployments for our HSHA setups. So let's take a look at our deployment for HSHA demo, and you'll see the differences here, where it's very similar in a lot of ways. However, when you take a look, you'll see that we have for replicas 2 desired, 2 updated, 2 total, 2 available, and 0 unavailable. And the strategy type is rolling update. It also follows a rolling update strategy, and there's a lot more defined here to enable automated provisioning based on CPU usage, which is an option, and I will talk about that here shortly, as well as adding more replicas to the cluster fairly easily. So pretty much the same otherwise, but we use a deployment for that just to make it a little bit more straightforward for managing the context. Okay, so let's go ahead and let's do a git pods and watch it. So we're going to see here that we have our CJOC, we have our demo controller, and then we have our 2 replicas. So let's go ahead and create a new controller. So we're going to create this. We're going to call this live demo, and we're going to make this a managed controller, which means that it's managed by our operations center. So we're going to hit OK. We don't need to necessarily fill all this out, but there are some key things that we have to do. So this is the normal provisioning setup for a Kubernetes controller using the CloudBees Operations Center UI. So you can select your Docker image. In this case, we're going to use the latest and greatest. And then the amount of space that we give it, that's fine. And then here is the new bit. This is high availability. Once you check this box, you get into the magic. Now, one of the things that you'll have to keep in mind is that the storage class cannot be EBS for this. So if we were to try to spin this up with EBS, it would fail because read-write many is not supported by EBS, but it is supported by EFS. So I have EFS set up for the storage class, and it confirms that it exists. Now, if we go to do the high availability, you have a few options here. You have managed controller replicas. This is how many replicas will be up and maintained up at all times. So we're going to leave this at 2. Maximum number of replicas is how many you want to be able to surge to in the event that you have a CPU overload or you have some problems. So if you were to say this is 4 and you were to hit an average CPU threshold on all of your existing replicas, it will spin up a number of replicas to help alleviate that stress to reach the maximum number over time. So for example, if we were to say 4, that and we had our 2 existing replicas hit 80% CPU threshold, it would create another replica to help alleviate some of that stress. Okay, so I'm going to leave this at 0 for now, just for the demonstration. We've already switched to EFS, and because I don't have a ton of resources on this cluster, I'm going to change it to 1 CPU and 2 gigs of memory for each replica. Okay, so the rest of this is all Kubernetes data, so you can do everything from setting file system groups to the liveness timeouts, the readiness timeouts, all that nonsense, as well as image pull secrets in the event that you're using a secret to pull your images down from a private repository, node selectors, custom YAML, and then of course our configuration as code. I'm going to assign the tooling bundle to it, which will automatically configure a few things, and the rest of this we don't necessarily need to declare for this demo, so we're not going to. Now, we want to make sure provision on and start on save is checked, because that will, once we hit save, it will begin to provision those controllers. So we're going to hit save, and we're going to go ahead and jump back. So you can see it's working on a deployment of 2 replicas right here. We're going to go ahead and jump over here, and you can see that our watched setup here has now created some pending container creating and running states for some new ones. So we had 4F, 4BX, and GCQQ2 for HSHA demo. And now we have 2 for live demo, JMPSW and K8X8C. So these are coming up right now, and these will be coming up over time. But what's really nice is once we get it to the created point, we'll be able to actually look at the logs, and we can see it come up just like a regular Cloud-based CI or Jenkins controller does. So really flexible to allow you to look into it. And in addition, you can kind of look at the logs here as well. And these logs will kind of dig into, give you some indicators as to what's going on. So in this case, it's waiting on the controllers to become available. They're awaiting headers. Nothing's come through yet. And that's because they're still coming up. They're still being created. They're still running. So once those become available, we'll be able to, log in and access them as normal. And they'll be able to be utilized pretty much right away. Now, we'll probably notice only one of these comes up to start, and the other one will still be running. It does take a little bit for the second replica to come up, but it is available as soon as the first replica is live and available. So now that this is running, you can see we had it connected. It installed the license, and we now have the managed master ID2. The managed controller here is defined, and it's throwing a 503, which means that it's still coming up and making the UI available. So we're not quite there yet, but it will be available here shortly, and you should see, right here. This right here is our instance. So why don't we go ahead and take a look at the logs for this. We'll follow the logs, and you'll see it comes up just like any other Cloud-based CI or Jenkins instance. It has to load, it has to process the Cask bundle, install plugins, make sure everything's available for that first initial setup and startup. So that's all becoming available now, and it should be available in any time now for us to access. So if we go to live demo, we should see a controller dashboard, which we do. So as you can see, Jenkins configured using Cask, and we are on live demo, the one we just spun up. So it is now available. Now we can take a look at the HSHA in the Manage Jenkins section, and we can actually take a look at, let's see here. It is Cloud-based CI high availability. Everything moved around because I zoomed in a little. So, all right, and then you can see we've got both hosts that are shown. So these are the 2 replicas, and we're currently on JMPSW. So using sticky sessions, you would end up ultimately being pinned to a specific session. And then we have a developer mode, which let's go ahead and save that, and you'll see that it shows you what replica you're connected to at the very bottom as part of developer mode. So if you're testing this, if you're doing your very first run through of this to see how it works and how it operates within your own infra, you can use that to kind of keep an eye on where you're being bounced to. Now, let's go ahead and talk about, now that we've demonstrated the setup and how easy that is, let's really quickly touch on how the jobs work. So I have a job here that's configured to, in essence, run to show what a failover looks like in a live context. So if we take a look at my pipeline here, it's very simple. It is using a Kubernetes agent and running a hello world echo and then sleeping for 2 minutes. So you can see, let's go ahead and do a build on this, and we'll be able to kind of see what that looks like. And then we'll go ahead and delete the pod that it's running on and see how that goes. So you can see it's managed by GCQQ2. So this is the controller that is managing it. So if we take a look at our pods, and we see that GCQQ2 is what's running it. So it's this one right here. Let's go ahead and copy that, and let's go ahead and delete the pod. So delete pod, and in the namespace, Cloud-based CI. Okay, the pod's been deleted. Now, what you'll see here is it's still running, but the pod is being deleted. Now, when the pod gets deleted, we'll see that it fails over. So we're actually connected still to the failed pod, but we're seeing a live update of the logs. So as you can see, it was sleeping, and now that the pod has been killed, it's dead, via crash or what have you, it's actually resumed it on another replica on 4F4BX. And it picks up right where it left off. It's still sleeping for 1 minute and 9 seconds. So the resiliency added here is so valuable. And this is one of the biggest changes that we've made to CloudBees CI ever. And this is probably one of the most interesting concepts that, at least to me, that we've come up with for handling high availability. And it's I don't know. I find it pretty impressive overall. So we're at about 5 minutes remaining. So I wanted to kind of get through that demo real quick. But yeah, so question and response time I think would be good. Cody, if you want to take it over from there. Sorry to spring that on you.
No worries. There's just about 4 buttons I got to click. So we've received, or rather we have time, it looks like, for one question. How does high availability relate to scalability and load balancing? And what techniques are used to ensure uninterrupted service during high traffic loads?
So for ensuring at least for CloudBees CI, for uninterrupted service during high traffic loads, in this case, specifically, it's a CPU metric at the moment. I think that we are looking for more metrics that we want to keep an eye on to ensure that those loads are distributed appropriately. But ultimately, we use CPU as our main metric. And as far as the scalability and load balancing goes, while they're 2 separate concepts, horizontal scaling and high availability, they do overlap a lot. So in the case of scalability, it gives you the ability to scale out horizontally with a single controller, whereas our normal recommendations, which this doesn't override those at all, but we always recommend to horizontally scale your controllers appropriately to ensure the best level of service for your end users. So it's just ensuring that, in addition to providing a highly available performance system, you're also giving them the ability to spread across and grow at whatever rate they need. And a lot of our clients, that's very quickly, and the needs are very high. And this sort of thing really helps to alleviate some of the stresses that can be caused, especially if they grow quicker than anticipated. And it can really buy you, in essence, time to properly horizontally scale your configuration in your setup.
All right. Well, guys, I know we need to wind things down, but Venkatesh, since you're here with us too, I want to hear from you before we cut things out. So what do you have top of mind whenever I bring up like closing thoughts or maybe anything that you feel is an absolute highlight takeaway from this last hour? What would you say?
Yeah, I just wanted to touch upon some of the points that I highlighted during my presentation as well. Following the AWS well-architected pillar and following the AWS well-architected tool to run the resilience tests for the workloads, and using the trusted advisor for checking the resilience of the AWS account as a whole. Yeah, just wanted to touch upon those points and re-emphasize that.
Awesome. Thank you so much. And Tim, any parting thoughts before I start shutting things down?
I think just to kind of echo the overall of my presentation is HSHA is a really important piece of your infrastructure. So if you're neglecting high availability while focusing on horizontal scalability, I think that's just as problematic as the reverse. And I think working together, they make for a really solid way to ensure that you have a performant and stable environment across your entire fleet.
All right. Well, Tim, Venkatesh, thank you so much for joining us today. I know we managed to pack a whole lot into 60 minutes, so Thank you so much for putting together your slide decks and your demos and sharing all of your expertise with us and our audience today.
Thank you.
Thanks for the opportunity.
Appreciate it.
Of course. So before we close things out, I'd like to remind our audience that we have been recording today's session. You will be receiving it via email here shortly, but you can also find it living on the DevOps website at devops.com/webinars, and it will be in the on-demand section. The two winners of our $25 Amazon gift card giveaway are Vijay N and Bilal A. So to Vijay and Bilal, I'll be reaching out to you here shortly to get your gift card over to you. If you don't happen to see an email from me, check your spam folder just in case it happens to be filtered out. I'd like to thank AWS and CloudBees for sponsoring our program today. And to everyone here still, there is a link at the bottom of the chat that will take you straight to our survey, and we would love to hear your thoughts, whether they're about today's program or upcoming topic suggestions. Let us know. We would love to hear from you. But either way, we hope to see everyone at a future Techstrong Learning Experience. Have a great rest of your day, and you may now disconnect. Thanks again to Tim and Venkatesh.
Thank you.
Thanks.